Hello, students. How are you? We're going to be having our science lesson on states and properties of matter. Now, this is a review class. We have done these topics before, but this is a review, so you can also you know master the topic very well. You're going to be answering some questions as we go along. Okay? All right, so let's look at the particle models. Particle models, we have solid, liquid, and gas. Remember, these are the three states of matter: solid, liquid, and gas. Example of solid is a metal. Example of liquid is water, or you can say juice. You can say oil. These are example of liquid. Then we have gas. We have gas we use for cooking. We have gas that we use in our air conditioner. We have gas that we use in welding, broken pipes, and all of that. Okay. Now you look at the particles in solid, they are fixed together. They are fixed together. And you look at the particles in liquid, they are not tightly packed together. And then, of course, the particles in gas are loosely packed. They are not fixed together. Okay. Next, we'll look at common gases at room temperature. What are the common gases at room temperature? We have nitrogen, we have oxygen, we have carbon dioxide, we have hydrogen, and we have water vapor. Now, the air around us, or the air around us, they have these gases. And if you can observe from the diagram you are looking at, nitrogen is the most. It has the largest amount, then oxygen, and then the others. Note that very well. Then, of course, we also have room temperature. I told you temperature from 22 to 26 degrees centigrade are referred to as room temperature. Okay. Okay, so let's look briefly at the properties of the solid, liquid, and gas as it forms the particle models. The arrangement of particles and movement of particles, and then of course you look at the diagram. For solid, they have regular pattern and they're close together. They vibrate around their fixed position, close together. In liquid, they are not regular pattern, they are irregular pattern, though they are close together, but their pattern is not the same, it's not equal like others. And they move past each other in random direction. Okay. In gas, the pattern is irregular, far apart. They move quickly in random direction, which means in all direction. They go in all direction. Remember, solid doesn't move. Solid particles don't move. They stay in one place. They're fixed in one place. Next, we'll look at solubility of solid. If you can remember, we talked about solubility of solids. Materials like salt, like sugar, which get dissolved in water, are water soluble. Materials like sand, chalk, powder, which don't get dissolved in water, are water insoluble. So any material that can dissolve in water like salt and sugar are said to be water soluble, which means they can dissolve, they are soluble in water. But sand, chalk, they cannot be soluble in water. They are insoluble, which means they can't be dissolved in water. They are insoluble. You can see example of sugar here, salt here. These ones are soluble, but sand is insoluble. Then apart from that, we also talked about the solvent property of liquids. And the two liquids we looked at were water and oil. Water can dissolve many solids, but oil cannot. And that is why they said water is a universal solvent. Universal means all over the universe. Water can be used to dissolve many, many, many solid. Water is a universal solvent. Don't forget that. Okay, if you look at this, look at solute. This is a blue salt, and this is solvent, which is water. And when they're mixed together, they form solution. Remember, I told you that solids are called solutes, and liquid are called solvents. And then when solute and solvent mix together, they form solution. You can see it here. When solute and solvent comes together, they form solution. Okay. Dissolving experiment, let's look at this again. This is sand and this is water. When you combine sand and water together, there's no solution. Why? Because water does not dissolve. Water goes down the cup, goes down the beaker, and you can see the water at the base of the beaker. No solution, which means they don't mix together. They don't mix. So in this case, no solution. Let's look at some very important thing: melting, freezing, boiling point of water. Freezing, melting, and boiling points of water. Okay. Example of solid here is ice block. You can see it here. And you can see the thermometer that is used to measure the temperature. And what is temperature reading here is written 0 degrees centigrade. So the melting and freezing point of ice is 0 degrees centigrade. You can see it here. Now look at the liquid at room temperature. What do we say is room temperature? From 22 to 26 degrees centigrade, you have the room temperature. So that is the value here. The liquid here is water. Then you come here, you see the gas. The water is being boiled and the gas is coming out, and which means at this point is boiling. And what is the boiling point of water? 100 degrees centigrade. This is a thermometer. What is a thermometer? A thermometer is an instrument that is used to measure the temperature of any substance. Thermometer is an instrument, it's an instrument that is used in measuring the temperature of any substance. Okay? So water at boiling point is 100 degrees centigrade. Next, we'll talk about evaporation. If you can remember, evaporation and condensation. And what do we say is evaporation? When liquid water turns into water vapor. When liquid water turns into water vapor. That happens by boiling or by increasing the temperature of of the environment where the water is. When you increase the temperature of the environment where the water is, or of the pot, or of the glass, or of the cup where the water is, there will be evaporation, which means the water will turn into water vapor. Okay. And of course, apart from that, when you can use another example of other examples of evaporation will be when you use a dryer to dry your hair, when you hang your clothes outside and it gets dried, when you use a fan to blow up your wet clothes and it becomes dry, That these are examples of evaporation. Okay. Of course, there are many other examples that we see. Even the rainfall is as a result of evaporation of water from the water bodies like the river, the sea, the ocean, and then it goes up, and then through condensation, like you can see here, through condensation, water vapor turns into liquid water. This is how rain falls, because after condensation, the next is what? After evaporation, the next is condensation. So the condensation takes place, and water vapor, which is a gaseous form of water, is turned into liquid water again. You can see the diagram here. Can you see the diagram here? Can you see it? You can see this flag. You can see this stuff here. That is the liquid water. That is the water vapor that is now turning into liquid in this cup. At this point is where, can you see this point? The water is boiling here, and this is the water vapor going up. If you cover this pot, for instance, you will see a lot of water. That is condensation. When this vapor has become liquid, that's condensation. And of course, this is an example of evaporation. As you hang the clothes, you see they will become dry after some time. That's what happens. Okay, I hope. Okay, let's go to the last slide. Now, the last slide tells us that salt can be separated from the solution through boiling and complete evaporation of water. You can see here, salt is poured into a cup, and then it's poured into your pot, and the pot is boiling. Evaporation is taking place. You can see already. Evaporation is taking place here. You can see evaporation is taking place. The salt is inside and the water. But now, as all the water leaves the pot, what will remain in the pot will be the salt, even though it was dissolved very well before. But after evaporation, the salt will remain in the pot. So if you're going to separate, if you want to separate salt from water, you mix the two together, and then you put them in fire, and after the water has finished boiling out, all the water have turned into vapor, you will see the salt. Okay, that is the brief summary of all that we have discussed in the last topic, and I know that you have really understood what I have taught you. Okay, now you're going to answer some questions. I hope you've been answering already. I believe you're already answering the question already. So whoever gets the highest or whoever gets some good points will get some good grade on Class Dojo. All right. Thank you. Bye.